Hello, in this demo about ACI and Red Hat Virtualization VMM domain integration, we will show you how to create EPGs and map to logical networks in a simple way. We have a fabric with a Red Hat Virtualization cluster connected made of two hypervisors, Red Hat Virtualization Host 1 and Host 2 managed by the Red Manager. We have an APIC to manage the fabric with a VMM integration. In a traditional network, to create a new network, we will need to create the SVI, the subnet, configure it on every node, configure the VLANs, configure the VLAN on every port, and then configure the logical network. Instead, on ACI, this is much simpler. We will have a bridge domain that will have the subnet. The bridge domain is created once and will be deployed automatically when we configure EPGs that require it. The bridge domain contains the subnet definition, and in our case also a DHCP relay configuration for the virtual machines to get dynamic IP addresses. We create a web server's EPG, and then we associate the EPG to the Red Hat Virtualization Manager. The admin doesn't have to know about the topology. This will create automatically the logical network with dynamic VLAN assignment that will be matching always. The server administrator then can create virtual machines and connect to the logical networks. Nobody needs to be bothered with the topology. Let's look at how we configure this with the APIC CLI. We begin by looking at the dashboard of the Red Hat Virtualization Manager. We can see there's a data center called DC2 and a cluster called Cluster 1 with two hosts, Rev Host 1 and Rev Host 2. There's a few VMs already configured, two of them are not connected to any network. Here we are now connected to APIC, where we're going to use the NXOS CLI interface to look at the details of the Red Hat Virtualization domain that has been already configured. We can see that there is indeed a connection to the data center 2 of the Rev Manager, and we can see on the inventory the two Red Hat Virtualization hosts and the virtual machines. Now we can configure the network. We select the tenant, ACME tenant, we select the application profile folder, application ACME Open Apps, and we will create a new EPG web servers. We have to associate it to a bridge domain that selects the subnet. We can look at the auto-completion to see the available ones, and we can look at one that we have conveniently configured with the name of the subnet. We associate it. Now we can see that there is no logical network on Rev Manager. We will configure an association to the Rev domain, Rev VMM01. Can configure it to deploy immediate and to push this configuration in a pre-provision mode. It is at this moment that we have created at the same time, we can see the logical network. The logical network, we can see it there. And also, this logical network has been configured on every host. Automatically, we can see that on host 1, on the bond uplink, the right logical network is configured. Similarly, on the bond is configured. It is at this moment, with this single action and this command, that we configure the logical network for every host and the clusters for this data center as well as on the switches. Now the virtualization administrator can configure the VM on the right network. We open a console. The VM has been configured to get an IP address via DHCP, and it's got it can ping the distributed default gateway in the fabric. So it's pinging the leaf. Now this is on the Red Hat host. This VM is running on the Red Hat host. We can actually look at the EPG and we can see that the VM is connected. If we look at show EPG web server detail, we can see this EPG is indeed mapped to the bridge domain, but also to the virtualization domain. And we can see the connected endpoints where we can identify the IP address 12.12.115 and the VLAN that corresponds to the logical network that we have created on the Rev Manager. What we can do now, for instance, is do a migration. The migration network is also configured to run on a logical network that is connected and backed by an EPG on the ACI fabric. Because the logical network that we have created, web servers, is available on all the hosts in the cluster, we can migrate to any host on the cluster. In fact, if we had more clusters in the data center, we could do a live migration to other clusters in the data center as well. While the migration completes, we can continue pinging, and of course we can continue pinging. Now we will look at the configuration using the graphical user interface. We look at the Red Hat Virtualization Manager, where we can see that we have deleted the previous server network. We can first look at the virtual networking, or we can see the inventory of VMM interfaces. We can see a VMM domain to the Red Hat Virtualization Manager, Rev Manager 1, and we can pull from it the inventory. For instance, we can look at the hypervisors that are running on the data center 2. We can see the Rev Host 1, Rev Host 2. Now we'll look at our tenant configuration. In the tenant ACME tenant, we have the ACME Open Apps. We can see that already we have an EPG called frontend mapped to the Red Hat Virtualization domain. This is the reason why we have this logical network already created. Now we're going to create a new one. We can right-click, create application EPG, select the EPG name, web servers. We will select a bridge domain. Again, for convenience, we can quickly identify by the name. And here we can select to associate VMM domain interfaces. It's important to understand that we are mapping here to the Rev Manager, but we can map at the same time to multiple virtualization domains, so we can extend the same EPG simultaneously to different hypervisors in a very simple way. Now we have extended the front-end and the web server EPGs to corresponding logical networks on the Rev Manager. We go to the Rev Manager very quickly, we can see the web server EPG appearing on the HTML5 interface. Not only it's been configured there, but it's also again being made enabled on the uplinks, LACP uplinks of each of the hypervisors. Then again, we can look at our web virtual machine, which has been disconnected before. Now we connect it to the web server's logical network. The virtual machine will get an IP address. It's running on Rev Host 2. We can see that it already got an IP address, the same one as before, and it can already ping again the distributed default gateway on the leaf. Let's look at how we can report it. So on the operational tab of the web server EPG, we can see that we are learning the MAC address and the IP address of the Web1 virtual machine as running on the Rev Host 02, reported by the Rev Manager 01 on node 2 of our pod on a particular VPC. We can now begin a migration. We will migrate to the Rev Host 1. So we're moving now to a different leaf pair. The migration is going on. And once the migration is completed, we're going to see that the APIC reports the migration has been completed and the Web1 VM is now running on Rev Host 1. So at all moments, we will have correlation between the virtual and physical for all the events that could happen. Now we will use an Ansible Playbook to create EPG, map it to the VM domain, and create the virtual machine and connect it directly. Let's look at the playbook that we will be using for this part of the demo. The playbook will have two components. First, to configure on APIC the EPG, and secondly, to configure on OVIRT the virtual machine and connect it to the right logical network. First, we will run against the APIC as a host using a local connection. We will have a variables file where we will pull in the tenant name, the EPG name, and so on and so forth. We will use two Ansible modules. ACI EPG will enable us to create the EPG. We will select as attributes of ACI EPG the tenant, the application profile, and the EPG that we will pull from the variables file. We're also selecting the bridge domain. Then we will use another module, ACI EPG to domain, to map the same EPG to the Rev VMM interface. The domain type is VMM, the VMM provider is Red Hat. Then we will use the OVIRT modules to create the virtual machine. We will run the host on an inventory file against the web group, which will create a Web1 virtual machine. First, we need to log into the OVIRT manager, and then we will clone the VM from a template. Then we will use OVIRT NICs to attach the NIC of the VM that we just created to the profile and network, which will be configured as the tenant name, IP name, EPG name. Last but not least, we will boot the virtual machine. Let's run the playbook with Ansible Playbook, select the inventory file, and the name of our playbook. Very quickly, we will see appearing on the left the EPG that has been created. Ansible is extremely fast for provisioning to APIC. The web server's EPG has been created and it's already been mapped to the VMM interface. Now we're cloning the virtual machine. That will take a little bit more time. In the meantime, we can see that indeed the web server's logical network has been created and has been again automatically added to the uplink interface on each of the hosts of each of the clusters. In our case, a single cluster with 2 hosts. Once again, we can see here the network is configured. Let's notice the label that ACI configures as part of the VMM integration onto the Red Hat Virtualization Manager. The cloning has finished, the virtual machine has been created, and is now being booted. So the play has finished, the HTML5 has not refreshed, but if we actually click again here, we can see that the web VM has been configured. We expand here, we can see already it's reporting its IP address. Let's console to it, and let's just confirm that we can indeed ping the distributed default gateway again on the fabric. So it is extremely easy to use Ansible, a single provisioning tool, to configure both the network, as we can see here, and the OVIL manager. Once again, the web VM appears connected in this case on the red host number 1. So we have seen some of the benefits and simplicity of using ACI with the Red Hat Virtualization VMM integration. It's very easy to extend EPGs to Red Hat Virtualization clusters. You can simplify configurations even if using the NXOS CLI compared to traditional networks where you have to configure box by box and be completely aware of the topology. Here we have seen that just a few commands on a single point of management enable you to configure both the network, regardless of how many switches you have, as well as the clusters or the logical networks mapped to each of the clusters. It also helps to enhance operations and team collaboration because the APIC visibility has greater information about the Red Hat virtualization domain. The Fabric administrators can actually use the same semantics and VM names to troubleshoot that the Red Hat administration managers are using. Finally, although we have not seen it in this demo, we will see in future demos that we can also enhance security and segmentation by leveraging the ACI contracts and distributed network policy, as well as simplify the migration from proprietary hypervisors. Thank you for watching.